Hey guys, welcome back. In this video, I want to prove that derivative of tangent x is secant square x from the first principle. We all know that from the first principle that derivative of the function, which is if y equals to f of x, and here is tangent x, then the derivative of this function is f prime of x is limit h approaches to 0 fx plus h minus f of x upon h, right? And here we have that derivative of tangent x can be written as limit h tends to 0 tangent x plus h minus tangent x upon h, right? And from the addition angle formula, we can write this tangent x plus h as tangent x plus h as tangent x plus tangent h upon 1 minus tangent h tangent x, right? So by using this and expanding this, we will get that limit h tends to 0 will be tangent x plus tangent h upon 1 minus tangent h tangent x minus tangent x all divided by h. Okay, now what we will do is we will find the common denominator by multiplying this denominator here to simplify this, and by doing this we will get limit of h tends to 0 tangent x plus tangent h minus tangent x plus tangent h times tangent square x upon h times 1 minus tangent x tangent h. Okay, now here we see that this tangent x and this tangent x get cancelled, and we can also group this tangent h and this tangent h as a common term to simplify this equation. By doing this, we will get limit h approaches to 0 tangent h 1 plus tangent square x upon h 1 minus tangent x tangent h. Okay, and from the Pythagorean identity we know that this 1 plus tangent square x can be written as secant square x, right? Plus tangent square x can be written as secant square x. By replacing this in this equation, we will get limit h tends to 0 secant square x upon h 1 minus tangent x tangent h. Okay, now we have simplified enough, and if we try to apply the limit here, then what we will do is that when h tends to 0, this tangent x will approach to 0, okay, and then this h will also approach to 0, so it will be 0 by 0 format. So it is inappropriate to apply limit right now. So to make it easier, what we will do is we will express this tangent x in terms of sine h and cosine h, as we know that tangent h can be written as sine h by cosine h. Okay, by doing this we will get limit h tends to 0 sine h, right, secant square x divided by cosine h times h 1 plus tangent h and tangent x. Okay, so by doing this, now we know that the limit of this part, which is sine h upon h, when h approaches to 0 will go straight to 1, and limit of when h approaches to 0 cosine h will also approach to 1, and here limit h approaches to 0, 1 minus tangent h tangent x will be also approaches to 1, because this will approach to 0 when h is 0, but we have here 1, so it will approach to 1. So finally what is left is this is 1, this is 1, and this is 1. So finally what is left is just here the secant squared x. Okay, therefore derivative of tangent x is simply the secant squared x, and which will also imply that derivative of secant squared x with respect to x will be tangent x plus c. And these are very important result when you differentiate the function which involves the tangent x or tangent theta, etc. I hope you might have enjoyed this video and understood this proof, and I'll see you in next video. Thank you.